Okay, so we're looking at Research Methods Booklet 2, and here we have another method of investigation that's non-experimental. So we've looked at experiments, and then we're now looking at non-experiments, okay, other methods that are non-experimental. First one we looked at was case studies. Second one now is the correlation. Okay, so it's page 7 of your booklet 2. Let's have a look at this. So what are correlations? Right, you need to be able to define it. It's a statistical technique that measures just the relationship between two variables. Okay, so as one varies, does the other one vary as well? Okay, so note it's not an IV and a DV, they are just called variables, because here we're not manipulating an IV at all. All we're looking at is the relationship between two variables. So what are they for? Well, they look at trends from lots and lots of people. It's a measure of analysing data that's already been collected. Okay, so we have two sorts. We've got a positive correlation and a negative correlation. Positive correlation is saying as one variable increases, the other variable increases as well. So for example, the one I've given you here is as rainfall increases, maybe the number of umbrellas sold increases as well. Okay, but we can see there that there could be other causes for us selling lots of umbrellas. So we're not saying it has any causal relationship, we're just literally noting that as rainfall in this particular data that we've gathered, as rainfall increases, umbrella sales increase as well. Okay, so have a think, and if you can jot down an example, we're going to have a look at those in class. So an example is one variable increases, the other one does as well. Negative correlations, on the other hand, are as one variable increases, the other one decreases. So for example, the more rainfall we have, maybe the less sunshine, the less hours of sunshine we have. Okay, so you can again carefully think about it, but write down one example of your own. Okay, we're going to have a go at this activity in class to just check your understanding. But let's move on a little bit with what else we need to know about correlations. So statistical tests produce a value, and this is actually known as a correlational coefficient. That's the name for it. It's a very fancy name. All right, but that's the name for this value. What you do need to know is that that number should be between -1 and +1. Okay, so the score is always going to be between 0 and 1, and it could be a minus number or it could be a plus number. The score will always be between these two numbers, as it were. Okay, so there's our 0, there's our 1, and effectively it's between a -1 and a +1. Okay, if you ever got a score that was something crazy like 2.63 or whatever, that means an error has been made with the calculation. It is wrong. It has to be. The way the calculation is set up has to be between -1 and +1. Okay, so one of these numbers. So what do we mean by the strength of correlation? Well, the strength, and this is the bit to remember, that once you've got this cracked, you know, it will be quite straightforward for you. The strength is the number that's closest to 1. Okay, now that means it doesn't matter whether it's a -1 or a +1, it's the number that's closer to 1. So here we've got look, 0.8 minus 0.8, that is a very strong correlation. Plus 0.8, a very strong correlation. But as we get down here, they're very weak and no correlations, there's no relationship. So it says 0.8 is stronger than 0.3. Look at that again, guys. This is what confuses people. Because it's closer to 1, it means it's a stronger correlation. Okay, so 8 is sort of 0.8, that should be, by the way, is 8 is bigger than 3, that means 0.8 is bigger or stronger than 0.3. Okay, so it also applies with minus scores. So for the strength of the correlation, you ignore the plus or minus sign. Alright, when deciding how strong a score is or a relationship is, ignore the plus or minus. The sign, plus or minus, just refers to the direction of the correlation. In other words, whether it's a positive or a negative relationship. Okay, so just listen to that again. The sign, the plus or minus, is just referring to whether it's a positive or a negative relationship. And it follows the plus is the positive and the minus is the negative. Okay. So what are the problems with it? What's the main problem? The problem is that correlations don't manipulate variables. all they are doing is measuring the relationship between two variables to see if there is any relationship. Okay, so it doesn't tell us anything about the cause of the relationship. Now, often you'll see in the paper that, you know, scientists say this thing causes another thing, and actually when you look closer, they're referring to correlational research. So it's wrong. It's the wrong message to send out. Okay, so look out for that. People who write the articles aren't always, you know, scientists. They don't always understand this, but a correlation is not telling us that one thing has caused another. Might be what people think is going to happen, but it's not scientific evidence that one thing has caused another. So we're going to have a look at strengths and weaknesses. I want you to read in your textbook and Flanagan to get the strengths and weaknesses, but I think you could probably sort those out yourself a little bit anyway. And then I'm going to get you just underneath these A to G to write down whether you what sort of coefficient you think it would be like, so what strength of relationship. Okay, and we are also in class going to have a go at actually drawing the scattergram. Once you've got this, it's very easy. Some of you will know this already from geography, biology, science, you know, maths, but some of you may not have come across it or can't remember it, and I just want to make sure that you could do a scattergram in the exam. Okay, so we'll have a look at that. One key thing to remember though with any graph is that you need to label correctly. So in the exam you get a mark for a correct heading. It has to be accurate, and I'll explain that a little bit, but basically it should have both variables mentioned, and that would be the same whether you're doing a bar chart, histogram, scattergram, whatever. Okay, so very clear what we call standalone heading with both variables, so both conditions of the IV and the DV in. And here, because we don't have an IV DV in correlations, you would just have both variables. Okay, so we get a mark for the heading, we get a mark for correct labeling of axes, and then a mark for some sort of correct looking scattergram. So that means basically just for labeling it you get 2 out of 3 marks, so it is really important you don't throw those marks away. Those can definitely be the difference between a whole grade, so watch out for that. So if you remember, we looked very briefly at correlational hypotheses. So there will be a significant correlation between variable 1 and 2. We need to change that into there will be a significant correlation between the amount of rainfall in a month and number of umbrellas sold that month, for example. That's a two-tailed, okay? Because we're just saying it's going to be a correlation. We're not saying whether it's going to be positive or negative. A one-tailed then is telling us what we think. All right, there'll be a significant positive correlation between the amount of rainfall in a month and the number of umbrellas sold. In other words, so as more rain falls, more umbrellas are sold. Or you've got an example of a negative one there. Okay, so those are just a reminder. And then we'll have a go at this little activity as well, and you know, we'll have a look at some of the exam questions.